Hello everyone. Today we're going to have the second part of the SAS Similarity Theorem. I will put the link of the first part in the description box below. SAS stands for side, angle, side, similarity. So the angle that if we look at this problem right here, the angle that we're referring to is this side right here. Again, this had been mentioned a lot of times in the previous video. These two angles are congruent because they are vertical. So these two angles are vertical angles. Notice that there are two triangles here. So the big triangle, which is located on the left, and the small triangle located on the right. So there are two triangles, the big triangle and the small triangle. Now, here's the deal. If side AB over side BD, they're coming from the same line. So side AB from the big triangle, side BD over side BD from the small triangle is equal to side EB from the big triangle over the side BC from the small triangle. Then these two triangles, the big triangle and the small triangle, are similar. If and only if the ratio of this two and this, the fraction, or this this side over this side is proportional to this side over this side. So if we are able to get them equal to each other, these two fractions, then they are similar. Now let's have an example to better see how this formula works. So let's take this example right here. So there are actually two ways that we can solve for x on this. So we're given two triangles here, and these two triangles are similar. So it says they're similar. So again, there are two triangles. We have the small triangle and we have the big triangle. Now to set up the fraction, you can actually do it two ways to do it. So first, let's start with I'll start with the small triangle over the big. So that would be 20 over x is equal to, since I started with the small, on the other fraction I'm going to start with the small too. So that would be 24 over 54. So that is, again, I'd like to repeat, that is coming from the small over the big triangle, the small over the big triangle. Okay, so let's do the math for this one. So we're gonna cross multiply these two and I'm gonna cross multiply that. So this would come out 24x. So that would be 24 times x equals 20 times 54. And so this is 24x, and then 20 times 54 is 1080. So that's 1080. And so from here, we are going to divide both sides by 24. So I divide that by 24, divide this by 24, so I can cross the 24 out, and x is actually equal to 45. So this side right here is 45. Now, what is the other way that I'm talking about? You can also do, since I started with a small triangle over the big, small triangle over the big, we can also do it the other way around. So if I start with 54 coming from the big triangle, so that's 54 over the other side is 24. And that is equal to, since I started with a big triangle, I will start with a big triangle on top. So that would be x over 20. So let's cross multiply this one right here. So cross multiply these two. So from here, we can therefore tell that 24 times x is 24x. And then 54 times 20 is 1080. And so we divide both sides by 24. We divide this by 24. As you can see, they are actually just exactly the same way, the same method. I mean, the steps that we are actually doing, they come out the same at this step right here. So x is 45. So both of them are getting 45. Now here's the thing that we need to remember. So if we start with the small over the big, you do the same thing here. We can never randomly pick numbers here and put it in fraction, it's not going to work. Again, I'd like to repeat, we can never randomly put numbers and come up with a fraction and solve for x. That's not how it works. It has to be with a pattern. If you start with small triangle over the big, start with small over the big. Or you start with a big triangle over the small triangle, you do also the same thing, a big triangle over the small triangle. So it has to be using that pattern. Now let's take another example right here. So this time around we have an expression. So instead of an integer, we got an expression right here. So it's pretty much the same thing. There are two triangles. We have the big triangle over there, and this is the small triangle over here. So we can set this up. So if we start from the big triangle, I can go ahead and say 2x plus 1 over the other side. On the small is 10 equals. Since I started with the big triangle, I'll start with 9. So 9 over 6. Again, do not randomly pick numbers and put them into fraction. It's not going to work. It doesn't work that way. So we're going to be cross multiplying these two fractions. So that would be 6 times 2x plus 1 equals 10 times 90. So then we distribute the 6 to both terms inside the parentheses. So that would be 12x plus 6 equals 10 times, oh, this is supposed to be 9. So that's just 9. So 10 times 9 is 90. Okay, so again, that's 9 right there. Oh, that's a typo right there. So 10 times 9 is 90. So I'm going to subtract 6 from both sides here. So subtract 6 and then subtract 6. So then we are able to get 12x is equal to 84. And from here, we're going to divide both sides by 12. Divide this by 12. So then we are left with x is equal to 7. Okay, so the x here is 7. And we're supposed to find the length of CE. So CE would be 2 times 7 plus 1. So that would be 14 plus 1 is 15. So this side right here is 15. Now we can check if these two fractions are equal to each other. So let's check over here. So again, the CE now is 15. So we're now checking. So this is 15 over 10. Is that equal to 9 over 6? So we can reduce this to lowest term. So this one goes by 5 3 times. This one goes by 5 twice. This one goes by 3 times. This one goes by 3 twice. So that means we have 3 halves is equal to 3 halves. And so that means the value for 12 is, the value that we have here, which is 15, is correct. And these two triangles are similar. If you find this video helpful, hit like and subscribe for more math videos. See ya!